going to present a project developing a forest reforestation chatbot using natural language processing by Omdena GIBDET Colombia and Mexico chapters together. So the problem here is that we have a new urgent need for better technological tools to support forest reforestation in the face of deforestation, illegal logging, and forest fires. These challenges harm biodiversity and essential ecosystems. The purpose of this project drives us to develop a chatbot based on open source large language models and other libraries that can address this issue by promoting reforestation practices and sharing vital information, making reforestation more accessible and efficient to the ones that have no access or have no information knowledge about it. So our sub-objectives are to learn about this vector databases and applying to specific PDFs that we will have, make the chatbot be present in a visualization framework, answer the questions through chatbot so that it can consider all the previous conversation in the same chat, and present the answers of chatbot letter by letter. So how we did this? So the first step that we took into consideration is to vectorize the information. First of all, in this part, we gathered PDFs so that these PDFs can be taken seriously, so that later it can be storage in a vector data store. And then we create the orchestration in Google Colab, where we use in this case a large language model open source that we can take into account for all the parts of the system, so that it could take into account all the further implementation, like the cache, where the cache is going to support us on saying, okay, what was the previous conversation, so that it could take into account for further prompts. At the end of the day, we deployed the chatbot in a visualization framework. So over here, we can see how is the architecture at the end of the day of this implementation. In this case, we saw many short courses of deep learning AI with the LangChain and so on, and also ChatGPT. But this was only the short courses that we later implemented. So as you can see, we see here the vector store loading, and also later the retrieval, where how we made the queries accordingly to the vector, so that later we can get the prompts and so on. So but at the end of the day, what we learned was about the large language model. That in this case we used the Llama 2 version of the 7 billion parameters. For the vector database, we used the technically Qdrant. For the part of the cache memory, in order to remember what was the previous chat, we used SQLite that is already behind LangChain, but we have to make the settings accordingly. And finally, in order to deploy a model in the interface of the chat, we use it Gradio by Hugging Face. So we learned all of this with the short courses that every single member of the project took in parallel. We had in this case discussion sessions about how we could go forward in around 2 months, so that everything could be really well implemented. We could see all the bugs. We could see how are some things that maybe some of the short courses are not seen, so that we can implement it accordingly, so that this could be really adapted and all the members can learn. So at the end of the day, we could make this happen with interactive chatbots in Llama 2 deployed in Gradio. As you can see there, we can make some prompts and so on, and the best thing is that it serves pretty well when we make shorter prompts. And in here is the 7 billion parameters of Llama 2. It lacks on some of the prompts when it gets larger, but for shorter it's pretty okay. So I really like that the part we can go forward for further research and other implementation of the vector data store, cache, and other LLM models. So I'm really grateful about all this experience, and really congratulate all the collaborators of this project. Thank you, and see you again.